Well, welcome. In this video, we looked at how to count strings of numbers or strings of outcomes involving replacement. So for example, we had situations involving a spinner where whatever you spun on the first time, that number was still there for the second spin and the third spin and so on. So it was a situation where we were dealing with strings of numbers, dealing with that included replacement. Well, there's plenty of other situations that involve situations that don't involve replacement. For example, here looking at this volleyball example. In volleyball, a team plays 6 players at a time, 3 at the net and 3 behind. How many different ways are there to arrange just the 3 players at the net from the 6 who are playing? So if you think about it, we have a situation involving 3 different positions. In that very first position, we have 6 players to choose from. Now, when I go to that next position, we've already, from those 6 players, we've already taken away 1 player to play that one position. So now instead of having 6 to choose from, we have 5 players to choose from. Once we've chosen a player to play that second position, now instead of having 5 players to choose from, we now have 4 players to choose from. So to figure out how many possible orderings we would have for those 3 positions, we would take 6 times 5 times 4, which would give us 120. So it'd be 120 possible different ways to arrange those 6 players. Now, an arrangement of teams, objects, or symbols, whatever we're working with, without replacement is what we call a permutation of those objects. We say that the solution of example 1 calculates the number of permutations of 6 objects taken 3 at a time. So the way that we would write that is using n, lowercase n, capital P, lowercase r to represent a permutation, where n represents the number of objects taken r at a time. So in this situation, we would say that this would be, we would have 6 objects taken 3 at a time. So that's how we'd represent this particular permutation. Now, there's a couple of ways that we could set up a permutation or find a permutation. So let's take a second, look at that, and let's look at some other examples. So this theorem is going to help us figure out how to determine the answer when we're dealing with the permutation, where again, n represents a total number of objects, and r represents, from those objects, how many that you're going to be taking at a time. Now this looks a little complicated, and I'll show you how to use this particular method, because it'll be important to know that method for a future example. But there's another method that we could use, and that's this. It would be taking n factorial divided by n minus r factorial. Now what does factorial mean? Factorial just means that you multiply all the numbers from that particular value all the way down to 1. So if we had 3 factorial, 3 factorial is the same as 3 times 2 times 1. So that's what the factorial does. So let's look at this first example. It says how many different 6-letter strings can be formed from 6 letters in the word palindrome without replacement. So the word palindrome includes a total of, if you counted up all the letters, there's a total of 10 letters. So our value for n would be 10. Out of those 10, we're picking out 6 different letter strings. And so our value for r is going to be 6. So we could write this as n, instead of n, we're going to have 10, so it'd be 10, capital P, followed by the 6, meaning that we have 10 items, and we're selecting 6 of them. Now, the way that we would use this particular theorem, this first method that they show us here, is we would set this up to say that we would have 10 times n minus, because 10 is our n, and then n minus 1, or 10 minus 1 would be 9. Yeah, let's do that. 10 minus 1 would be 9. And 10 minus 2 would be 8. And 10, we keep going all the way down to 10 minus r plus 1. In this case, we would have r is 6. So we're going to end once we get to 10 minus 6, which would be 4, plus 1 would be 5. So we're going to end when we get to 5. So it would be 9 times 8 times 7 times 6 times 5 is where we would end that. And if you'd multiply those together, that would give you your answer of 151,200. So again, the way that we use that is we start by taking and starting with our 10.
And then we would go down all the numbers all the way down to the place that we end is found by taking n minus r plus 1. So in this case, 10 minus 6 plus 1 gives us 5, so it tells us when we would end that string. So we get 151,200. Now, again, there's another way that we could use this, or find this, by using factorials, and that would be taking 10 factorial and divide that by n minus r. So in this case, 10 minus 6, or 4 factorial. Now your calculator will find this for you. If we go to our calculator, the way that we find our factorial button is if you go to next to this G, you see the question mark. If we select our exclamation point there for factorial, so 10 factorial divided by 4 factorial, hit enter, and you get your 151,200 that way as well. So either method works, doesn't matter which method you use. You get the same answer either way. So why don't you try this next one on your own. Here we have an art gallery that has 12 paintings by Renaissance painters, but only enough room to show 8 of them. And how many ways can they arrange 8 of the 12 paintings in the 8 places they have for them? So why don't you take a second and attempt this one on your own. So pause the video and hit play when you're ready to check to see if you have the correct answer. Okay, let's see how you did here. So in this situation, there is a total of 12 paintings, and out of those 12, you're going to be selecting 8 of them. And now, so we could write this as 12 permutation 8. And you could do this using either method. So if you use the first method, what I did here is I was figuring out where I would have to stop at. Well, 12 minus 8 plus 1 is 5. So starting with 12, I would go all the way down to 5. Oops, forgot a parentheses here. And when you do that, you get 19,958,400. Or personally, what I prefer doing is using the factorial method. And so if I do that, I'd have 12 factorial divided by 12 minus 8 factorial, or 4 factorial. And as a result, you get the same number, 19,958,400. Now let's look at this next example. This next example is kind of tricky. We're going to solve this equation. We need to figure out what my value for n would be here. Now, in order for us to figure this out, we're going to have to use that first method. So for this one, I would start with n factorial. Start with n times the one below that. The one would be n minus 1, and then I would have n minus 2. Then I have n minus 3. Now to figure out where I have to stop at, I'm going to stop at n minus r plus 1. In this case, r is 6. So negative 6 plus 1 is negative 5. So I'm going to keep going until I get to n minus 5. So what I've just done is I've expanded out the n permutation 6. So now we're going to simplify the right side. So we're going to have 17 times n permutation 5, so it's going to be n times n minus 1, n minus 3 times n minus, whoops, missed one, n minus 2 times n minus 3. In this case here, I'm going to end at n minus 4. So now I want to solve this equation. Now this might look pretty complicated, but it's really not. What we're going to do is we're going to divide both sides by n. And you can see then you'd get rid of the n's. Divide both sides by n minus 1, and you get rid of n minus 1. Divide both sides by n minus 2, you get rid of the n minus 2's. Divide both sides by n minus 3, we get rid of the n minus 3. Divide both sides by n minus 4 to get rid of the n minus 4. And now on the right side, we're just left with 17. On the left side, we're left with n minus 5. So I have this equation, n minus 5 equals 17. Add 5 to both sides, and we get 22. So our answer here is that there would be a total of 22 items. In many situations, the number of permutations of all the objects in a set is desired. So when that happens, and we have n permutation n, so we have n items, and we're choosing all n items, the total possible ways that we could arrange those n items would be n factorial. And let's define 0 factorial. 0 factorial is always going to be 1. That is very important. Anytime you have 0 factorial is not 0. 0 factorial is 1.